This is a Cisco access point. This is something that users can connect to gain access to the network. And of course, it needs an Ethernet cable in order to transfer the data into the infrastructure. And it will probably connect to some sort of wireless LAN controller. But it also needs power. And there's a connector here. We could plug a power brick into this and power it. Although that's another line that we have to route to this. And if this is up in the ceiling and we have a couple cables that need to go up to it, and we have hundreds of these around our campus, then that can be problematic. Another way that we can distribute power to some of these equipment, like voice over IP phones and this access point, is power over Ethernet. Now, some equipment come with a power injector. So this is what a power injector looks like. It's got two ports here. One would plug into your switch, and that would give it the Ethernet, the data connection. And then the other one plugs into this device right here, and it passes through that data connection, the Ethernet connection. But you also plug it into power, so in addition to the Ethernet, it also provides power to this device right here. There's also a lot of switches that have ports on it that can provide power to equipment like this. And I have one of those, so let's take a look at that and see what some of the commands we'd use on that switch. Let's first of all just take a look at some of the power that's able to provide to the different ports. So I'm going to use the command show power inline and hit enter. And we can see all of the different ports on this switch and how much power consumption they're using. Now, I don't have anything plugged in here that's consuming power, so it's just a bunch of zeros here. And the max that can be provided for these particular ports is 15 watts. So this gives us a view into what kind of power can be provided to these different ports. Here I'm on Wikipedia, and it's showing the power over Ethernet. So I can take a look at this power over Ethernet, and I'm going to scroll halfway down because what I'm going to find here is that there is actually different amounts of power that can be provided. And so here are the different classes there are and the amount of power that will provide. So different equipment needs different levels of power. Now, it'd be dangerous if my switch automatically assumed that the other device needed power and just started delivering power to it. That could damage certain equipment. So what has to happen is that this device needs to talk with the switch and let it know that it needs power. So what happens is I plug this into the switch, and then they start doing this really low level conversation, just back and forth, some really basic signaling to say, I need power to start up. And then the switch provides that power and gets this up and running. And what it will do is, since there's different classes, it will provide the max amount of power that it can have to power up this device. Now, that could be somewhat wasteful. It could be providing power that it doesn't necessarily need to be providing. And so what it will do is it will then go through a negotiation. So this device and the other device will negotiate, but it needs to discover these devices and do that negotiation. And it does it through one of our discovery protocols, either the Cisco Discovery Protocol or LLDP. We're back on the Wikipedia page where it's talking about the different classes, and then it goes into LLDP and how we can use LLDP, or Link Layer Discovery Protocol. But of course with Cisco Discovery Protocol can do that as well. So if you see a test question talking about a phone not starting up or a access point not starting up or something wrong from that perspective, then you might want to think, okay, power over Ethernet, and maybe it doesn't have CDP or LLDP up and running on it.